In this video, we're going to start to look at monosaccharides, better known as sugars. So let's just start with all our monosaccharides, our aldoses to be more precise. And so what is a monosaccharide? It's an aldehyde or ketone that is straight chained, and it has at least 3 carbon atoms, and it's polyhydroxyl, which means it has a lot of OHs on it. So if your carbonyl group is an aldehyde, that is, it's C double bond OH at the very top like this, we call our sugars aldoses. So you can have an aldotriose, aldotetrose, aldopentose, and an aldohexose. And these names just come from how many carbon atoms do you have. So you see that we can have a lot of aldoses. However, for biochemistry, the only ones that are really used are the ones that are in squares here. So these are the sugars I would like you to know the names and the structures of. Now let's look at the most important sugar in biochemistry, and that would be glucose. So glucose has 6 carbons, and 4 of those are chiral. So carbons 2, 3, 4, and 5 are chiral. 1 and 6 aren't. One's where your aldose is, and carbon 6 has 2 hydrogens. So glucose has 16 different stereoisomers. Each carbon can have their OH on one side or another, so it has 2 to the power 14 different, or 2 to the power 4 different possibilities. Now, most sugars in biochemistry are what we call D. And the way you tell between D and L in a sugar is that you look at the chiral carbon furthest away from your carbonyl. And if the OH is on the right, we call that a D sugar. If the OH is on the left, we call that an L sugar. Most sugars are D though. And sugars can have what we call epimers. So if the configuration of one chiral carbon is different and only one chiral carbon, we call those 2 sugars epimers of each other. So the epimer at C2, that is the OH is on the other side, is called mannose. So we can go back to our previous image, and if you look at glucose and mannose, you can see the only OH position is at C2. So glucose and mannose are epimers of each other. So those were the aldoses, and here are the ketoses. And this is if your your carbonyl group is a ketone now, where it's in the middle of our chain. And since we have carbonyl as our ketone, you actually lose 1 chiral center compared to the aldoses, right? So here, 1, 2, 3, 4, 5. So we have 5 carbons, but only 2 chiral centers. While in the aldoses, we would have had 3. Here, we only have 3 ketoses that are very important: dihydroxyacetone, ribulose, and fructose. So I would like you to know the name and structure of the sugars. That's it for our introduction to sugars. I will see you in the next video.